Okay. So what was supposed to be in the middle there was actually a git push. So you've got your all the commits done in your master branch, but you haven't sent them up to remote yet. So actually, I can hop out and show how that works. So what this has done is, so this is cleaning up after ourselves. So the master branch has all the commits. We don't really need the emergency branch anymore. But remember that the emergency branch is effectively just a pointer. But it's one of those things, it's not consuming any resources if you leave it around, but it's just going to be in your list of branches, so it will cause things to get increasingly cluttered if you have a list of branches that you're not actually using anymore, that you're just done with. It's going to make it harder for you to read your list of branches. So generally I would advise cleaning up your branches after you're done with them. And branch -- delete emergency. But again, the thing to keep in mind is that's not doing very much. All it's doing is getting rid of the tag. So it's really fast, and it doesn't delete any commits. Well,
can I hide branches?
Can you hide branches?
Don't want to delete them. Just don't want to see them by default when I go get branches.
Not that I know of. You can push a branch to the remote repository and then not pull it to your local repository. Which might be, so it would just mean that if there are, effectively what it would mean is that if there are any commits in that branch, Git wouldn't bother to pull them to your local machine. Maybe a slightly more complicated thing that would kind of do that. So what Paul asked about is there any way to hide branches? And the answer is mostly no, because you have a list of branches that are in your repository, and that's the list of branches that are in that Git repository. But there is a way to hide the branch of commits. So if we use this as a diagram. So we have a branch here that's got 3 commits in it, and it's got a pointer to it that's called branch B. So the thing to keep in mind is that the commits and the tag labels as a branch are totally separate from each other. They are completely independent of existence. So that means I could delete the branch B tag, and as long as I remember somewhere the address of DC3D77B, that little arbitrary number that's down here, I could use git commands to get that commit back out of the Git repository. So, which would be kind of a hidden branch. I guess it would be a branch that was no longer tagged. So where that can come in handy is if you accidentally delete things that you didn't intend to. If you get rid of a branch, and as soon as you've gotten rid of it, you realize, oh, wait a minute, I didn't actually merge that in, and I really needed the changes that were there. You can actually get it back, because you can scroll back through your log, you can find the ID of the commit that represented that branch, and you can use some of the more low-level Git tools to pull that out and then reattach or put a branch label back on it again so that you can get at it. Eventually, they're called commits that don't have anything pointing to them or aren't in a chain that's got anything pointing to the end are called orphaned commits, and they will eventually get cleaned up because they will just take up a lot of space and be kept them forever. The default is, I think it might be every 30 days that as you run git commands, it'll run the garbage collection and clean up old orphaned commits. So it's a fairly large window that you could get stuff back. But it's not exactly a hidden branch. But maybe sort of what Paul might have meant, or so it's something that would be sort of like a hidden branch. If you do git branch, so git branch, gives you a list of your local branches. So we deleted emergency branch, so we don't have that one anymore. But we've still got feature 1 branch and the master branch. These are the local branches that are currently on our machine, and we have explicitly checked them out. We can do branch.a, which, again, A is just telling it to tell you about all the branches in the repository. So branch.a. So that tells us about both the local branches and the remote branches. So again, these are all just tags of things that exist. So this is telling us about our same 2 branches. We've got feature 1, we've got master. Keep in mind master is highlighted because it's the one that we currently have checked out in our working directory. And then this is the only remote branch that we know about. So our remote server has a master branch. It gets a name of remote. It's on our origin repository, and it's a master branch. So now this is the branch that our master branch points to as its origin. So anything, whenever we push or pull from master, it goes into the remote origin master branch. But there can be more. Let's do an example. So GitDocs is a project that I've been working on. And you can see, so the details don't matter, but you can see I've got a bunch of local branches, including the master branches. This is stuff, various things that I've been working on. But if I do git branch-a, I see a whole bunch of other ones. So I still see origin master, but now I also see pointers to a whole bunch of other branches. Some of them are ones that I created, some of the ones that other people created. This would be a place for these. Some of them are ones that haven't been cleaned up and they probably should. For example, these ones are the ones that I worked on, and the code's already been merged into master, so they could be deleted. And then I also have pointers to the upstream branches. So the upstream repository is the repository that's actually by the maintainer. So if we look at our diagram again, in that repository, I'd be contributor 1 with my local, I have my own remote copy and a copy on my laptop. And the maintainer has their own remote copy and their copy on their laptop. And my repository has pointers, or my repository on my laptop has pointers to my server for pushing and pulling changes to my remote repository. And then it also has pointers to the maintainer's upstream version for pulling down changes from that maintainer. And so you can see the branches that I have locally, I haven't checked out all of the branches. So they're sort of hidden. I may not have copies. If I haven't explicitly told Git to pull down all of the commits that are involved in all of these branches, there may be commits that I haven't pulled. So that can be useful if things start to get large and if there's lots of different branches. But you only need this particular branch. You say, I want to pull down the master and the branch that I'm working on. And Paul, I think you had a question.
No, I think I'll follow up.
Okay.
As you were explaining it. So Git has tags too, right?
Yes, Git does have tags
So I
too.
could just make the branch that I want to hide, make it tag, and then delete the branch.
Yes. So Paul just says that, so for taking something and making it not look like a branch anymore, but still keeping it around, that you could just point a tag at that commit and then delete the branch. And that is entirely true. So the branches and tags, as they're recorded, are basically exactly the same thing. It's just another pointer at a particular commit. And it's just the branches are treated as branches and the tags are just treated as labels. So the Git utilities are going to offer you an opportunity to do other stuff with branches, but they don't do with tags. But they're largely interchangeable. Or you could take a tag. So, for Paul's example, you started something as a branch, you decided you don't want to do any work on it anymore, but you still want to hang on to those commits. You tag it to make sure that the commits don't get orphaned and thrown away. You delete your branch, so you no longer see that in your list of branches. Then, time goes on, you do other stuff. And then at some point in the future, you realize, oh, okay, I do actually want that code back now. You'd go branch from that tag, and then keep going. And your first step would be, you now merge in all the changes that have happened in master since you did that.
From that picture you showed, it looks kind of centralized. What if maintainer goes down?
George's comment was that in this diagram it makes it look kind of centralized, and it does. Because this is assuming that you have basically a single maintainer who's doing the merging. So his question was, what happens if the maintainer disappears? And the answer is that in some ways the contributors just have to coordinate to find a new maintainer. Because the contributors can have, if the contributors have pulled down all the commits, they can have a full repository in each one of their machines. And any one of them could either re-upload that repository to a central server for coordination, or they could even be sending patches in between each other. So, like, let's see, an example would be in the Linux ecosystem. There are Linux maintainers who will maintain their own branches or their own repositories of Linux that some people will use. Either they'll have bug fixes that are still waiting to get included in the mainline, or they might have like specialized things that a very small community use. They've got some device driver that for some reason can't go into the mainline. So we'll say they're contributor 1. That contributor 1 could be, I'm missing another diagram. Probably didn't make this too complicated, but so contributor 1 and contributor 2 could pass changes in between each other. They wouldn't have to go through the maintainer because they each got, they could send each other pull requests and merge in changes. Contributor 1 could pull down contributor. So if the maintainer could say, contributor 1, could you please review contributor 2's pull request? I don't have time to figure out if this is good code or not. So contributor 1 could send a request to contributor 2's remote repository, pull down those commits into their repository. It'll get listed as a set of commits in a branch in their local repository. They review the code, and they either say to the maintainer, yeah, that's good, or that's not good. But they can do all of the same things that the maintainer can do. I guess effectively the maintainer is just a agreement, or again, Linux is a good example because it's kind of the big and the most complicated version of Git. That Linux is the maintainer of the mainline kernel by agreement, and that the majority of people will go to the mainline kernel to get their kernel. But that's not an artifact of Git. That is just that everybody has still decided that Linux is trustworthy enough, and that the work that he does and the number of people who support the work that he does mean that's generally the good version of Linux that you want to get. But based on the Git model, suddenly people could decide that there's another maintainer that is doing a better job of it, and they start to pull from that person's repositories, and that person slowly becomes the canonical version of Linux. And there's nothing that would have to change about how Git is maintaining the version control.
How about branch mergers? I was reading that it looks like Git has the best merging algorithm, because the other ones like Subversion or other versioning systems sometimes gives you false positives or negatives or messed up things.
George was commenting on the effectiveness of Git's merge algorithm. And so I guess it's not directly related to the underlying, how things are stored underlying, but it's a lot of, I've found and a lot of people have found that it's very effective, that it will figure out, it will merge together things the right way most of the time. And it will give you a clean display of what's wrong and give you good advice on how to start fixing it most of the time. At the end, I can see that I don't actually have a demonstration of merging because that's yet another step. But that's something we can try to do a demo of if we have time.
Is Git using its own version of diff and patch, or is it using the standard version?
As of now, I don't actually know. Earlier in its history, Git was more, so the question was, is Git using just the standard diff and patch utilities? I know it's using the standard formats. Like it's, if you export a patch, it's using the standard patch format. If you do a unified diff or if you do other kinds of diff, it's just using a standard format for those kinds of things. As of now, I don't know if it's actually using the standard utilities themselves. So Git used to be much more a collection of shell scripts and small C programs back when it was originally started. But to improve performance, it has become much less of a set of shell scripts and more of just a pure C program. There is a library called libgit2, which has been kind of absorbing more and more core functionality and becoming the central part of how Git is implemented. So I don't know. My guess would be there's probably things that have either been, they used to use like the diff and the patch utilities directly, and then either they're using a library or they've implemented something of their own.
So you can commit the branch, the full post, right? And then so if you delay your local branch, then you can always get it back.
So the point was that if you push up a branch and it commits to your remote server, then you could then delete it on your local repository and you still have it on your remote server. And that's right. So you would then be, the situation you would be in would be as if those commits in that branch had already been put on your server and it just meant to pull them down. So there's a way, so for example, if you were maintaining branches that you wanted to keep for the long term but you weren't going to be working on them, you could tag them, push all the commits up to the server, delete the tag of the branch on your local machine, run garbage collection, and then it would delete all those commits on your local machine, if it was a space issue. So where were we in the story? So we finished doing our emergency fix. We put it in master. We deleted our emergency branch. And then we want to go back to work. Emergency is finished. Now we want to go back to working on the feature that we were working on before. So we check out feature 1. We do git rebase master. So this is where what we want to do is we want to say, okay, I know that I've now made a bunch of changes to master. I want to bring them into my feature 1 branch. And I want to kind of stick them into the right places in the history of feature 1, that it looks like the feature 1 branch started from the point where those changes were made. So this actually is a nice description of what it's doing. So it takes the pointer for your branch back to the start of master, and then it tries to apply all the commits that you have in feature 1 on top of those commits, effectively as if you were just rewriting them. So sometimes things will get into conflict, and Git will give you the opportunity to resolve those conflicts within your commits. But in this case, the changes are very simple, so so there aren't any conflicts. So apply all those commits, and then it's done. No problems. So we do a status, and we can see we're on feature 1. We've got a clean working directory. There's no changes. There's no changes that aren't committed. And we can look at our log file, and we see our whip commit. So actually, I'm going to hop out and do it in the pager because it's easier to see. So we see that we've got our work in progress commit. But if you remember, it used to be this branch contained the work in progress commit, the second branch commit, the first branch commit, and then our initial commit, and nothing else. But now, we've got a work in progress, second branch, first branch, emergency fix, and the initial commit. And if we went back and looked closely at the commit IDs, we would see initial commit is still the exact same ID that we've seen everywhere because the initial commit hasn't changed. Our emergency commit is the same ID as the one that we saw in the emergency branch, because in this case it hasn't changed. The content hasn't changed, and its parent is still the initial commit. All of the other commits, on the other hand, will have different IDs from what they used to have now, or what they used to have before. Because their content is the same, but their parents are now different. So this first branch, its parent commit used to be the initial commit applied, but its parent is now fixed the emergency. And all the other ones are changed in the same chain. So this is, we are letting Git rewrite our local history, which is very useful, but also very dangerous. So if I had published these changes to somebody else, and I did a rebase, their copies would now be very confused. So they would have a copy of a commit that was called second branch commit, published at a particular time, but it would have a different number on it, which would make it look like it was a different commit. It would have a different set of parents, and they would then have to do some work to figure out when, or as they got new changes, they would have to do some work to figure out how am I going to make all these changes work together. But for my local branch, I can happily rewrite history because I'm the only one who's worrying about it. I'm not merging any other things back into my, or I'm not taking any changes and merging them into my branch. I'm only pulling in changes from the other place. And now what it means is this branch will now merge tidally back into master because it's as if I took it away from master right away. With the emergency fix, it's just part of what I've done. So for example, if I'm writing software, I can now, I've got the emergency fix in place. I can rerun my tests, I can verify that my new change works correctly in the context of the emergency fix. Questions? So we've got our work in progress is sitting in this commit here. But this is, it's something that we have completed. So it's not actually, this isn't actually a commit that we want to publish to anyone. This could be, our software could still be, could be broken. Because this was just something we did because we had to stop working. So now we're going to undo that commit. So we use git reset head caret. So, and Git has a few different kinds of notation, or has this caret notation for telling you what you want to point at. So, head is a pointer to whatever is at the very end of the branch that you're working on. Caret tells you to point to the commit after that. So, if we go back and so we've only done our whip in this case. So on this branch, the head of this branch, the second branch commit, which is 6AFEA3, blah, 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 blah. If I wanted to reference the next commit in the branch, I could call it head caret, and that will take me one commit back. 2 carets will take me 2 commits back, 3 carets, 3 commits back. So what I did by saying git reset head caret was I said I wanted to take this branch back to the second branch commit, and I wanted to get rid of the whip commit. And reset by default does what's called a soft reset, which means it gets rid of the commit, but it keeps all those changes and it sticks them into your working directory. So we do a status, we can now see we have that work in progress file that's sitting as an untracked file. And Git doesn't think that it's included in a commit anymore, doesn't think that it's included in an index. So now we can continue, we're basically back into, we put Git into the exact same situation we were in before we went to do the emergency fix. So we now can carry on, keep working, and make the changes as we were originally intended to. So Git has preserved those files because we told it git reset with no options, which means to get a soft reset. You can also do a hard reset, which will just throw away all the changes. So if you had a commit that you realized was not what you wanted to do at all, you could do a git reset -- hard head caret, and it'll just throw away those changes completely. Most of the time, that's not what you want to do. Sometimes it is, but I found, generally in my experience, you've got to be careful when you use -- hard. So, we're continuing on with our work in progress. So, we're going to move around the whip file. We're going to call it now finished work. We're going to add finished work to the index. So, this will actually, it looks like it's missing something, but it's not. So Git will automatically figure out that we have changed whip to finished work when we tell it to add finished work. And we'd say, I finished the feature, figures out there's one file change, one insertion. But we decide, so one file change, one insertion, we got to that point. But I'm going to decide that I actually got that message wrong, and my finished work was actually supposed to be something else. And so I go, I've done this into finished work, make a new commit, do the whole thing, Git tells us, okay, it did that safely. And we go, so that's better. But then I think about it some more and decide that's terrible grammar. And I'd like to write it out properly. I like to commit, lets everybody know that I'm fixing my grammar. Well, the same thing, tells me about what it's going to do. But now I have kind of an ugly history. So if I'm sending this up to my maintainer, I'm telling the maintainer about all the details of my poorly working brain in order to get to the point of the feature. So the feature that I'm trying to build is all of these 3 commits together, but it doesn't clearly look like that. So the maintainer has to look through and see, this, obviously this is a simple example, but if it was a piece of software and it was like, okay, I wrote this method, but then, I realized I named these things badly, or I mistyped something. and then I fiddled and made the changes here, and then, oh, I did another thing, and I did that badly. But that means for someone to understand the whole change, they now have to read the first thing, and then read the second thing, and think about how those changes fit into the first thing. And then if I did it again, they've got to read the second thing and figure out how that fits into the first thing and how that affects the second thing. So you are putting more pain on your maintainer than you really want to. So what we can ask it to do is take those commits and just kind of smush them together. So basically, again, to rewrite history and pretend that I'm smarter than I am and I did this all properly the first time. So, now this is the part of my script that didn't quite work. So what I've done is I'm doing an interactive rebase. So this has brought me into my Vim text editor, and it's generated a text file that just has all of my commits with their IDs and their messages, and then I can decide which ones are going to be included. So I'm just going to show you what it did, because unfortunately the way that works, it hides it right away. So, git rebase interactive master. So that's doing the same rebase command that we ran before to bring feature 1 up to date, but we're telling it, I want to do this interactively, I'm going to change stuff along the way. And I do it here. So, what do we say I wanted? I finished the feature. Here's the actual message that I want to say. I implement the feature. And nobody really cares that I didn't do it properly the first time. So I want to keep my first 3 commit messages. I want to squash away the other ones. And actually, I'm going to use Pixel. So, and you can see described below, you can see various things that you can do. So one of the things you can do is you could just be editing your commit message. You could decide, I didn't express myself very well when I described this change, and I just want to change that. I don't want to change the contents of the commit. You could re-edit the entire commit and have it go partway through and then actually go in and change something in that commit itself. Or you can do a squash or a fix-up. So squash and fix-up do almost the same thing, except fix-up will throw away the extra commit messages, and squash will give you a chance to combine them together. So in this case, these commit messages are not very useful, just I did a dumb thing and now I'm fixing it, so I don't care. So I'll use fix-up and it'll just throw them away. So, any questions before I save this file and make it go away? Again, so this is just my text editor. So Git's hanging around in the background waiting for me to save this file and exit the editor. And when it does, it lets me know successfully successfully rebased, updated the pointer from refs header feature 1. Do a git show, and I can see that it's still on feature 1 branch. The working directory is clean, there's nothing to commit. And if I look at the log, all I have is I finished the feature. And then if we hop over to actual command line, so you can see the log as I finish the feature. And if we look at the unified diff of the log, all we see is the change to go to I have done this. But all of our other changes have disappeared because they all got subsumed by this main change. So this, again, if it was a more complicated example, this could, if I'd added multiple lines to this file, they'd all be included in this one commit. But in this case, it all boils down to just one change. now I'd be ready to push that up to my maintainer, and my maintainer would be able to read that a lot more easily than a bunch of different random changes that, so that they don't want to or need to know the details of what it did. So again, this is one strain of thought in people who use Git. There are other people who will say, no, I never want to rebase. I want to know all the details of the process that I went through. I want to know exactly the bad things I did, the good things I did, the places I made mistakes. I've found that I don't like that. I've found that it's kind of making it, as I said before, making the commits into more of a story of the change that I want to make, and all the nitty-gritty details of I made this mistake here, I made this mistake there, aren't very useful for communicating to someone who's upstream what I actually want to do.